we were discussing, we have discussed the chemical properties of metals, we have discussed the physical properties of metals, of bases, also reaction with bases. Okay, today we're going to discuss metallurgy. Okay, what we are going to discuss, or should I start with acid or base? Tell me, beta.
Metallurgy.
You are not, please increase your volume. I'm going to start with acid base. Okay, beta. Because revision is very important, and I should start with acid base. Okay. If I ask you that what are acid, let's start with acid and base. Okay, half chapter generally in half year examination, metallurgy means occurrence of metal does not come in examination. If it is coming, then let me know. Okay, I'm going to revise the previous chapter that you have already studied. So let me discuss that chapters. Okay, please turn on your camera. Other students, let my request, Abir and Faiz, please turn on your camera. So if I'm talking about acid base, so what are acids? Tell me, what are acids? What are acids? Is there anyone who can tell me what are acids? Yovita, can you tell me what are acids? You are muted. Twice. Okay, let me explain what are acids. Acids are those substances. Acids are those substances that dissociate H plus ions in aqueous. Okay, that dissociate H plus ions in aqueous. Okay, means if I'm saying that what are acids, so acids are those substances that dissociate H plus ions in aqueous. They can easily dissociate their H plus ions in aqueous. They are considered to be as acids. Okay. So when you add it, you get simply these are means if I'm saying for example HCl when added to water, it will gives you H plus ions, and this H plus ions when added to water plus Cl minus ion, and this togetherly form hydronium ion, H3O positive. That is called hydronium ion. What we call it? Hydronium. You understood? Understood?
Yes, sir.
Okay. Faiz, are you there in the class? Faiz?
Yes, sir. Yes, I am there.
Please turn on your camera.
Yes.
So if I'm saying acids are those substances that associate H plus ions in aqueous. Going to the next part is, have you noted this one? And what are bases? What are bases? Those substances that dissociate OH negative ions in aqueous. Correct? Understood? Okay, then for example, NaOH, okay, when added to water, it will give you Na positive and OH minus. AQ, I'm writing that it is in water. AQ means aqueous. AQ indicate करता है aqueous. Aqueous means in water. In water. Okay, if substance is something is written that NaCl aqueous, so it means that it is in water. NaCl aqueous, this means that it is in water. Understood? Understood? Tell me, beta, understood?
Yes, sir.
Yes, sir.
Okay. Now moving to the next part here is that you have probably listened that there are so many compounds that when added to water, they don't show the acidic property, still they have the hydrogens. For example, what type of question is being asked? For example, if I'm having a test tube, okay, test tube, and it is containing the HCl gas. This is dry HCl gas is placed in it, okay. Dry HCl is containing, okay. And when I passed, when I'm having a litmus paper over it, okay, and this is a blue litmus paper, litmus paper. You understood? Blue litmus paper. So when I pass blue litmus gas over it, this is also dry blue litmus. This is also dry. Both are dry. So when blue litmus paper, okay, litmus paper comes in the contact with acid, okay, then it become red in color, okay, it changes color in acidic, but here no change will be observed, okay, here no change will be observed. Can anybody in the class can tell me why? Can anybody in the class can tell me why? Why no change is observed? When blue litmus paper is added to dry HCl gas and dry HCl gas is passed over it, okay, then why the color of the litmus paper do not change? Why? Because acid shows the property, because acid shows their property in aqueous, water में ही शो करती है, और aqueous में ही क्यों? Why in aqueous? Why acid shows their property in aqueous? In water, acids when are dry, they don't show their property. Why? Because it is not the acid that is showing the property of acids. Okay, it is the H plus ions that get dissociated, after when it is added to water. Okay, so if I'm saying that HCl when added to water aqueous, then it gives H plus ions and Cl minus ion. When H2SO4 is added to water, okay, then it gives 2H plus ion and 1 SO4 minus 2 ion. And similarly, when CH3COH is added to water, this gives CH3COO minus and H positive ion. Okay, and when ethanol C2H5OH is added to water, it remains same. C2H5OH. It remains same. It does not change. It remains same. C2H5 plus water does not change. So these substances show acidic property. Why? Due to dissociation of H plus ion. Dissociation of H plus ions. You understood? But here no dissociation of H plus ion is taking place. In this, no dissociation of H plus ions takes place. So no acidic property will be shown. No acidic property will be shown. You understood? So it is the aqueous. When acid are not added to water, they don't dissociate H plus ions. For example, if I'm saying that acid is dry HCl gas, no water content is present, it will be HCl only. No dissociation of H plus ions. अब जब कोई dissociation नहीं होगा H plus ion का, तो what would happen? If there is no dissociation of H plus ions, then no acidic property will be shown. No acidic property will be shown. You understood? Everybody understood? Tell me. Other student, please turn on your camera. Abir, Shoaib. Now you understood, everybody? समझ आया कि acids are those substances that shows their property only in aqueous water. If there is substance that is added to water and still it is not showing its acidic properties, it's not showing its acidic property, what does it mean? It simply means that there is no dissociation of H plus ions taking place, and that's why no acidic property will be shown. Got it? You understood? One more thing is that sometimes we have such type of question that we generally get in the examination. For example, ammonia is a base. NH3, it is a base. Means ammonia when added to water, it turns red litmus to blue. Red litmus to, okay, it turns red litmus to blue. Why? Okay, ऐसा क्यों करती है? जबकि अमोनिया के पास तो कोई भी H plus OH ions नहीं, there is no OH ion present with the ammonia. Okay, ammonia does not. Why it is showing basic behavior? Turns blue litmus to red. What does it mean? Means it's showing basic behavior, i.e. showing basic behavior. Why it is showing basic behavior? Can anybody in the class tell me? Abhi, can you tell me why ammonia show the basic behavior?
Because it can produce H plus ions.
Because
It can produce H plus ions in aqueous solution.
if it can produce H plus ions, then it must show acidic property, not the basic behavior. Jubita, any idea? Okay,
It produces OH minus.
it produces OH minus. There is no OH ions here. Okay, indirectly I need to explain you this one. Okay, let me explain. Actually, what happens? There was a scientist named Bronsted-Lowry. Okay, and this concept is very important. He also gave another definition of acid and base. According to him, acids are those substances that dissociate or that donate H plus ions, H plus ions. Okay, and bases are those substances that accept H plus ions, accept H plus ions. There is no OH ion definition is here. No OH ion. If there is something that is accepting the H plus ion, that is considered to be as base. Okay. And if someone is some substance is donating the H plus ion, then it is considered to be as acid. And what was according to Arrhenius concept? According to Arrhenius concept, please note it down. Have you noted? Guys, have you noted?
Sir, 1 minute.
And what according to Arrhenius concept? What was according to Arrhenius concept? According to Arrhenius concept, actually, acids are those substances. Acids dissociate H plus ions, and bases dissociate OH negative ion. Bases dissociate OH negative ion that we have written previously. Okay. So let me explain you the things clearly. Okay, let me explain. What happened? For example, if I'm having something like if I'm having a base, like for example, HCl. Actually, Bronsted-Lowry definition is more correct than Arrhenius definition. Okay, Bronsted-Lowry concept is more accurate, or we can say that it is more. I can simply say that a Bronsted-Lowry concept is more accurate and more easy to understand. Okay, actually, when acid are added to water, Okay, they form hydronium ion, H3O positive. Actually, H plus ions independently cannot exist. Independently cannot exist. Independently can't exist. Okay, it cannot live alone. If I'm saying H positive and independent exists, no, there is no independent exist of H plus. It is added with water and form H3O positive and Cl minus. This is called hydronium ion. Hydronium ions. Okay, and this is the hydronium ion that is responsible. This is the hydronium ion that is responsible for. This hydronium ion is responsible for what? Tell me. This hydronium ion is responsible for acidic behavior. Acidic behavior. Responsible for acidic behavior. You understood? You understood, beta? That
Yes.
hydronium ion is responsible for acidic behavior. Okay. So if there is no hydronium ion formation taking place, if there is no water, no hydronium ion will be formed. Like in the dry AcidsAll gas, there is no water, everything is dry. So no hydronium ion will be formed. And similarly, we can say that if there is no hydronium ion is formed, there will be no acidic property. So here, according to Bronsted-Lowry, this HCl is donating H plus ion to this one. So it is donating. So it will be considered as acid. And H plus ion, if water here is accepting. So here, according to him, it is considered to be a base. Water is acting as a base here. You know, water is neutral, but here water is acting as a base, according to Bronsted-Lowry concept. Understood? Because water is donating, HCl is donating H plus ion to this one and form H3O positive. As a result, water is accepting the H plus ion and it is considered to be a base. Now understood? Understood? Got it? Understood? Now moving to the next point here. Let's move. If I'm having ammonia gas in H3. Okay, and ammonia gas is added with water. Okay, added with water. What happens to it? Actually, I'm just writing here for better explanation. I'm writing here water as HOH. Okay, here only, just for better explanation, I'm writing here HOH as water because water is H2. Okay, and here the water, the ammonia can accept the H plus ion. Water also dissociate H plus ion, OH minus ion. If there is someone who can accept the H plus ion of water, then it is possible. Okay, so ammonia can accept the H plus ion of water and form NH4 positive and OH minus ion. Okay, here that's why the OH minus concentration is increases. Okay, so that's why ammonia is accepting the H plus ions. Okay, H plus ions from water, so it is acting as a base. And since water is just they're donating its H plus ion to the ammonia, it is considered to be as acid. Okay, so water can act as acid or it can act as a base. Understood? Shweb, are you getting?
Yes, sir. Time. Yes, sir.
Vita, you understood?
Yes.
So ammonia can act as a base. So actually ammonia is accepting the H plus ion from water and from ammonium ion and OH minus ion remaining. So this OH ions make this acid, make the solution basic. That's why when ammonia gas is passed through water, it form basic solution, and that's why it turns red litmus to blue. Understood? It turns red litmus to blue. Understood?
Yes, sir.
So let's move further. So I'm going to give you the question here. Write down the two questions in the homework you have to write. That ammonia do not contain any OH negative ions. Still it act as a base when added to water. That's first question. Second question is both ethanol C2H5OH and glucose C6 and aqueous C6H12O6 contain hydrogen, contain hydrogen, still they are not characterized as acid. And the last question, why the color of blue litmus paper of dry blue litmus paper do not change when dry HCl gas done. Note it down. Done. So, can anybody tell me, Shweb, can you tell me that ammonia does not contain any OH ions, still it is characterized as base when added to water? Can you tell me how it is characterized as base?
Yes, sir.
Maybe. I'm asking the hint for the first question. How will you write the answer for this first question? Ammonia do not contain any OH negative ion, still it is acting as a base. You can tell me in Hindi if you know, if you are good in Hindi, then you can tell me. Ammonia do not contain any OH negative ion, still it is act as a base when added to water. I was just explaining here. The same thing I was explaining here. I was explaining here. This case of ammonia. Ammonia when added to water. यही तो था ऊपर लिखा था हाँ ऊपर. Tell me. Shoaib.
Yes, sir.
कुछ तो बोलो. Try something.
Yeah. So H ions cannot act independently.
Abir, can you tell me? Abir.
NH3 accepts H ions from water and disassociates OH minus ions and acts as a base.
That's why the concentration of OH ions, since water is having one H plus ion and one OH ion. Okay, that's why water is neutral at normal condition, because it is having equal value of H plus ion that show the acidic property and equal number of OH negative ion that show the basic property. If this number of H plus ion is accepted by something, there is something added and that start accepting the H plus ions, then this will get become less in numbers and this will become more in numbers. That's why the ammonia act as a base, because it increases the OH ion concentration in the solution. Let write please this answer. Please write the answer of this question. Ammonia when added to water, it accept the H plus ions, sorry, OH negative ion, sorry, H plus ions, it accept the H plus ions of water and form NH4 positive ions. As a result, As a result, the OH ions concentration increases. As a result, the OH ion concentration increases. Okay. As a result, the OH ion concentration increases, and thus basic. Give the answer for the question number 2. Jupiter, you need to give the answer for the question number 2. Tell me, you are muted. What was the question?
Both ethanol and glucose contain hydrogen, still they are not characterized as acid.
Because when they are added to water, they don't dissociate the H plus ions. They don't give the H plus ions. They remain in the original form. Okay. Like the HCl when added to water, it form H positive and Cl minus. Okay. And similarly, when other acidic substance also when added to water, they give H plus ions if they are acidic. But in ethanol and glucose, when they are added to water, they don't give the H plus ions. And since the property of acid is due to the dissociation of H plus ion, if there is no dissociation of H plus ions taking place, there will be no acidic evolution. Okay, so acid shows only their property in water, in aqueous. And if something is added to water, it is not dissociating the H plus ions, then that will not characterize as acid. Okay, so let you write this answer also. Note it down. Since glucose and ethanol, when added to water, glucose and ethanol when added to water, they don't dissociate, give H plus ions. As a result, if there is no H plus ions, got it? Yes, Faiz. Are you there? Faiz, sorry, Faiz, no, Faiz. Where have you gone? Faiz, are you there? Okay. Tell me, next question. What was the next question? Dry HCl gas when passed to blue litmus paper, it does not show, it does not change the color of blue litmus to red. However, acid change the color of litmus paper, blue litmus paper to red. But HCl, when dry HCl gas is passed to dry litmus paper, so it does not change. Can you tell me, Jovita, the answer of this question? Why dry HCl gas when passed to
So
blue? Yes.
So HCl only reacts with aqueous solutions.
Yes, because there is no water content present.
Yes.
Okay. If there is no water content present, then what is going to happen? There is no water, dry
there will
HCl and dry. There will be no,
Acidic behavior.
because there will be no H plus ions and no H plus ion, no acidic. So no change in that. Okay. But if you take the litmus paper instead of dry, if you take the litmus paper, some moist litmus paper you have taken, blue litmus paper, blue moist litmus paper. So when it come in the contact with dry HCl gas, the dry HCl gas will come in the contact with the moisture of the litmus paper, it will dissociate the H plus ions, and as a result, what is happening? What would happen?
Blue litmus will turn to red litmus will.
Blue litmus will change into red. Very good. Okay. So next question I'm going to give you in homework. Okay. You have to write in homework. Okay. Now moving to the next part is, let's move further. Physical properties of acids. What are the physical properties of acids? You know, you are very much familiar with this one. Physical properties of acids. What are the physical properties of acids? First one is
Right. Can I say
yes,
acids are sour in taste?
they are sour. Sour in taste. That taste, okay. Sour in taste. Okay, second.
They turn red litmus to blue litmus.
Okay, red litmus to blue. I'm just writing in short. Third.
pH level is less than 7.
Okay, pH level is less than 7. Okay. Are they good conductor of electricity in aqueous? When red to water, will they conduct electricity?
Yes.
Yes. Good conductor of electricity. Good conductor of electricity in aqueous. Are they corrosive in nature? Corrosive in nature. Understood? Understood? Yogita, Shoaib, Abir.
Yes, sir. Understood.
Yes, sir.
So let's move further. Note it down. Listen. Down first.
Noted, sir.
Next topic is acid-base indicators. Let me explain you what are acid-base indicators. Actually, what if I'm just going to explain you here is that what are acid-base indicators? There are some substances that changes their color or smell. That changes their color. Means there's some substance that changes their color or smell. Okay. If they are changing their smell, they are considered to be as olfactory indicators. And if they are changing their color, so this is simple indicators. Okay. So I'm saying that if we have some substance that are added to acid and base, and they are changing their color in acid or basic solution, they will be considered as what? They will be considered as, tell me. they will be considered acid base indicators. So note down the definition that those substances that changes their color or odor, means smell, when added to acidic or basic medium, they are called acid base indicators. Okay, they are considered to be as acid base indicators. And we generally have litmus, methyl orange, phenolphthalein. Okay, in neutral condition, they have the color of means neutral condition means the color of litmus is purple, methyl orange is orange, and phenolphthalein is colorless. In acidic medium, litmus changes to red, methyl orange changes to red, and phenolphthalein changes to colorless. And similarly, in basic condition, the blue, yellow, pink. Okay, noted. Understood? Please note it down. When you're done, please write.
Noted, sir.
Noted. Shuaib, noted.
Yes, sir.
So let's move further. If I'm saying here that we have the litmus paper, okay, and it's that's litmus paper are of two types, red and blue. But if I'm saying litmus is it's also coming in the liquid state. Also, it is the extractions of a plant. Okay, name of that plant, lichen extractions. Okay, so generally lichens, when we extract the juice from the lichens, okay, the litmus means indicators, acid base indicator is obtained, that is called litmus, and its natural color or its neutral color is purple. When it is added to acid, it becomes red in color. When it is added to base, it becomes blue in color. So these are the indicators. Got it? And now coming to the point that is not the important for the examination view, but let me explain you that how do acid base indicator work. Okay, how do acid base indicator work and how they are working. So let me explain you here that there are some substances in chemistry that have different colors in their ionic as well as in their atomic form. For example, let me explain you. This is copper. Copper solid. You are very much familiar that it is brown in color. Brown in color. Understood? That is brown in color. But if we have copper 2 positive ions, okay, we have copper 2 positive ions, then it would be what the color of this one? Copper 2 positive. The color of copper 2 positive is actually, it is blue in color. It is blue in color. You understood? It is blue in color. So if something, when it's, what is happening here? The difference is that copper when loses 2 electrons, Copper solid when loses 2 electron, it become copper 2 positive and 2 electron is being lost and will become blue in color. This is blue. This is blue in color. This is what? This is brown in color. Okay. Similarly, the acid base indicators also work on the similar phenomenon. Okay. Let me explain you this one, that how they work. For example, if I'm having methyl orange, or if I'm having suppose phenolphthalein, okay, the acid base indicators are actually weak acid or weak base, or weak base. They are either weak acid or they may be weak base. You understood? They may be weak acid or weak base. Understood?
Yes, sir.
Now moving to this point here, that suppose phenolphthalein is, we represent phenolphthalein as HPH. This is phenolphthalein. Phenolphthalein, okay. So phenolphthalein is HPH, means it is acidic indicator. Acid, weak acid. We can say that weakly. It is weakly acidic. It is weakly acidic in nature. Understood? How it is? It is weakly acidic in nature. So when we added this one, let's suppose, if I add this HPH to some acidic, strong acid. This is strong acid. Strong acid. Okay. Then in place of strong acid, let's Shoaib, look at this. जब strong acid होता है तो उसके सामने weak acid अपने H+ ion को dissociate नहीं करते. They don't dissociate the H+ ions. Means weak acid do not dissociate the H+ ions in the presence of strong acid. So for example, if this is strong acid, then this will dissociate its H+ ions, and this weak acid, it will remain same. It will remain same. You understood? It will remain same. Similarly, when we have HPH, okay, or you can write it H. It's like this. Okay, H is capital. HPH. Okay, when it is added with some NaOH, some base, then it in this strong base, whether it is a strong base, then it can dissociate this H positive and pH minus plus Na positive plus OH. So you understood?
Yes, sir.
Now you need to keep in mind here that this is very, very important to you, and that you need to understand it. Okay. That what is this? Why it is not dissociating? In case of a strong acid, the weak acid does not dissociate. This is called common ion effect. We call it common ions effect. In chemistry, we call it common ion effect. So because when it is also dissociating, what it will give? It will give HPH and pH minus. But since strong acid is giving it H+ ions, the weak acid does not dissociate. So it remains in its original form. Okay. But when this is added here in terms of base, so there is no H+ ion present here. Look at this. There is no H+ ion present here. कोई भी H+ ions नहीं है NaOH के पास. So what is happening? What is going to happen here? That it will dissociate each other because there is no common ion. There is no H+ ion dissociation. NaOH के पास तो H+ ion है, so there is no H+ ion dissociation. So it will dissociate. But in case if it is a strong acid, it will not dissociate. So you need to keep in mind that when it comes in the form of this one, it has different color, and when it is in the form of this one, it has different. When it remains in its original form, it is colorless. And when it remains in this form, it becomes, when it gives pH minus ion, it becomes spring. This is a funda behind this, the change of acid and base color, that they are either weak acid or base, or strong weak acid or weak base. When they are added to acids or base, they dissociate. Sometimes they dissociate, and sometimes they don't dissociate. So if they dissociate, they have different colors. If they don't dissociate, they have different colors. Okay, understood? So similarly, when phenolphthaleins come in the state of it remain in its original form HPH. So it is colorless, and colorless, and it does not, it remain in its original form in a strong acid. Why? Because it will not dissociate it H plus ions, because weak acid does not dissociate it H plus ions in front of strong acid. Strong acid dissociate it H plus ions more. Okay, it means more preference will be given to the dissociation of strong acid. Okay, so it will remain its original. This is the reason why H plus ions or this work. Okay, I understood, Abhi.
Yes, sir.
Everybody, do anyone want to note it down, or should I move to the next slide? Understood. Now, this is the main concept. This is not going to ask in the examination, so no need to write this one. Just listen to that. This is the funda behind this, or this is the main concept that why this is working. This is the main phenomena, or we can say that the main cause that you need to keep in mind that this is being asked in the examination, that acid base indicator are actually weak acid or weak base. You need to keep in mind this. You have to write this statement. This is being asked in the examination, that what is the nature of acid base indicator? Either they may be weak acid, they may be weak base. Okay, have you noted this one? Done.
Then so
Sure. Okay,
Yes,
let's
sir.
move to the next slide. Now let me explain you what are weak, what are strong acids, and what. Let you write place this one. That olfactory indicators are those indicators that changes the smell in acidic or basic medium. Example like clove, onion, vanilla essence, etc. Please note it down. What are olfactory indicators? Shreya, please note it down. Olfactory indicators. And what are natural indicators? There are some natural indicators that are not synthetic, and they are generally like vegetables, flowers, something else. Okay, so natural indicators are those indicators. These are also natural indicators, you see. So, but they don't change their smells. Okay, so if I'm writing here that natural indicators are those indicators that are obtained from organic substance like turmeric, red cabbage, litmus. These are the litmus are the extractions of lichens. Extractions of lichens. Lichens.
Done, sir.
Done. Noted till here. It was the
Yes,
B
sir.
shape written.
Yes, sir.
Have we done? Done?
Yes,
Can I
sir.
move to the next slide?
Yeah.
Okay. So here we are having this one. This is the chemical properties of acids. We are going to discuss that are what are the let me discuss one more thing here before going to this question. So let me explain you. Let me explain you first strong acid and strong base. What are weak acid and weak bases? Okay. So let me explain you this one also. What are strong acid base? Strong acid base indicators. What are strong acid base indicators? Can you tell me? There are some acids that when added to water, they completely dissociate their H plus ions. Okay. For example, if I am having here that is H plus ions and Cl minus ions. For example, if I'm having some acid like HCl, HNO3, if I'm having H2CO3, okay, CH3COOH, okay, like if I'm having HCl, HNO3, H2SO4, okay. So this one, and this one. Okay. Okay. These three are actually when added to water, they dissociate their H plus ion completely. They dissociated their H plus ion completely. Okay. Means if I am having 100, suppose if I am having 100 H plus ions. Sorry, if I am having 100 HCl molecule. HCl molecule is 100. Okay. So when they are added to water, everyone will get dissociated into H positive and Cl minus, H positive and Cl minus, H positive and Cl minus, H positive and
Sir,
Cl minus. Yes.
sir, can I leave the class because I'm having max tuition also today?
Right now.
Yes, sir.
Okay. Oh, it's 34 right now. Okay, beta. So that's all for today.